Welcome back everybody, and thanks for stopping by. In this video, we're going to be diving into our next technical topic, and that topic, as you can see by the description below, private VLANs. Now, if you've never dealt with a private VLAN before, or maybe you have, good for you. If you haven't, we're going to be talking a little bit high level as to what the private VLAN is, how it works, that type of stuff, because it's really important to understand what it's supposed to be used for, because there's a common misconception that when you have the private VLAN that, well, it just everything should work, right? Like, well, most of the time that would be true. So what we're going to be focusing on is understanding the first half, and then we're going to actually go through the implementation, which isn't too terribly difficult to follow along with. So we need to understand what it is that the private VLAN does, how it does it, why it does what it does, and all of that good stuff that goes along with it. So, enough yammering about that. So, the private VLAN is actually broken up into three separate, two major areas. So you have what they refer to as the primary VLAN, and then you have the secondary VLAN. Now, the idea here is to take what you have configured ahead of time. So the primary VLAN is going to be no different than any other VLAN that you have ever worked with. So this is going to be your standard and your extended VLANs. And if you know what ranges those are, excellent. If you do not, that is going to be 1 through 1001, and then 1006 through 4094. 96, something along those lines. I don't remember the specifics. Not important to me. But you have your standard and extended VLANs. Those numbers don't change, okay? But what actually ends up happening is the private VLAN, it enables a capability of separation at the VLAN level. So the idea is like this. If I have a switch here and I have a switch here, then I have a couple of devices connected into the switch. And there's an uplink to the switch, and then maybe we have the outside world up here. There's some sort of connectivity to the switch, right? Well, if I'm gonna have, let's say this is VLAN 100 that's sitting on these two ports right here, then I have a trunk link where VLAN 100 is allowed to cross, and then VLAN 100 is up here, and then the communication is able to go from here down to here and back. So it's bidirectional communication. Well, that's fine. That's basically what a primary VLAN does. It's communication. It allows communication to jump from a switch to another switch over a trunk link. Well, that's great. The problem with that, though, is if I decide to extend the network down to here and down to here, and I configure this as a trunk link and this is a trunk link, and I put 100 down here and 100 down here, and I put a couple of devices, what ends up happening is you start to scale it out. Now, scale normally is not a bad thing. The problem with this is you're stretching the VLAN across multiple switches, and there's really no way to filter that. Now, we talked about the VLAN ACL in a previous video. Now, we could implement that, however, that's done on a per switch basis. So I'd have to create that ACL on multiple switches, implement it on multiple VLANs. It just gets kind of hairy. What Cisco developed was a secondary VLAN. The secondary VLAN was a way to provide a level of hierarchy in the VLAN architecture. So the idea is you have your primary VLAN. Well, let's just assume for the moment that is VLAN 11. That's the VLAN we're going to be using. So VLAN 11 is your primary VLAN. Normally, that's where all these ports are going to be placed inside of his VLAN 11. Now, currently, all of my ports are in VLAN 10. That's a simple VLAN change. Not that big of a deal. Now, in this case here, we're going to create VLAN 11 as the primary VLAN. Then we're going to have two, what they would refer to as secondary VLANs, or what I like to refer to as sub-VLANs. And this is where the actual segregation, which is what private VLANs is supposed to accomplish, is going to happen. So we're going to do, we'll say 10 and 20. Okay, so these are going to be our sub-VLANs. Now, why they're sub-VLANs is you're trying to provide a level of hierarchy. So what's going to end up happening is there's going to be a mapping between 10 and 11 and 11 and 20, right? All that stuff is going to happen. So you might say, well, why not just create VLAN 10 and VLAN 20, and then just place whatever devices need to be in VLAN 20 and VLAN 20, and place what port devices need to be in VLAN 10 and VLAN 10. Well, that works, but then you're still down to the aspect of, if I have multiple devices connected in this VLAN and I have multiple devices connected in this VLAN that should not be able to talk to each other, if I need to segregate them out per device, what does that require me to do? A different VLAN per port. That's not scalable. Well, in most cases. And it's more overhead, it's more VLANs, etc., etc. Now, even if I had created all these VLANs here, let's say I create, 21, 22, 23, 24, 25, so on and so forth. I create all those VLANs, and then I create an SPI for each one, so 21, 22, 23, 24, etc. And then I give a default gateway, and then I do some sort of aggregation to where there's just a default route pointing northbound up this way. That would work, right? Because then you're terminating the layer 3 on the switch. But what if you can't do that, or you're not doing that? The problem you're going to run into is that you need to take into consideration what the VLAN, again, is doing. Just like we talked in the VLAN access map, what is the VLAN allowing to happen? It's allowing communication with all the devices in that VLAN. It doesn't matter what the VLAN number is or what its purpose is for, right? It's a broadcast domain. So what should happen is devices in that broadcast domain should be able to communicate with one another. Well, you might say, okay, where would I normally see this? Where would I normally apply a private VLAN? And the simple answer to that one is a DMZ. And I might say, why a DMZ? Well, a DMZ is typically going to be a place for externally facing traffic, or I should say external sources that need to or want to access resources that are internal to your organization. It might be I might be me as a consultant that need to connect into your virtual environment to help you do a migration. I have plenty of customers that I worked with where I've had to set up remote access VPN to allow me to connect into the network, and I had to connect to the DMZ. I connect to a jump box, and then I'm RDPing into something else, or I have an RDP session over the VPN to a remote desktop connection somewhere in the DMZ, and then that allows me specific access to different parts of the network. There's all different ways to look at it, but what you're trying to do is you're trying to limit the east-west communication whenever you need to. So there's the second portion of this whole design is the port roles, and there's 3 of them. The first one is going to be the isolated port. Now, this is a port type that you assign. You have isolated, you have community, and then you have promiscuous. Now, the 3 different types here is isolated. It's pretty obvious what this one's supposed to do. This one here is supposed to allow communication on one port. So if I have a device that needs doesn't need to talk to anything else except for itself, whatever that might look like, it can go ahead and be placed in an isolated VLAN all by itself. That's the whole purpose of that. Then you have a community VLAN. This is where you have 2 or more devices that need to be able to communicate with one another, east-west. Now, in a situation like this, you might say, well, I don't want to just give both devices full access to whatever it is that they need to. So how would I take this a step further and be more restrictive to this level, or at this level? And the answer to that question is the VLAN ACL. You can create an ACL per VLAN, or you can create an ACL and then map it to at the VLAN level and do that. And then you have promiscuous. Promiscuous, what this basically means is it's able to talk to either the isolated ports or the community ports. And those ports are able to talk to the promiscuous port as well. It's a bidirectional communication. So this will be the primary VLAN. These will be the secondary VLANs. And this guy here, we might put in, have defined as isolated. This one might be defined as community. And then what we could do is on the trunk link going up northbound, we could put this as a promiscuous port. We're actually not going to be using a trunk link. We're going to be using an SVI. So we'll go through the configuration and talk about how that comes into play and all of that type of stuff. But that's basically what's happening here is, from a grand scheme of things, that's how this is all coming into play. So the idea is that traffic comes in on VLAN 11, but is destined to this guy. Or traffic comes in and is destined to VLAN 20. It has to come in through the SVI and is forwarded down and go from there. So what we're going to do is we're going to go ahead and pull up PC1, which is our switch, and we're going to go ahead and start configuring this. So one of the first things that we're going to do is we're going to go ahead and we're going to say that we're going to place 4C47, which is going to be PC1. PC1 is going to be placed into the isolated VLAN, where PC2 and server 1 are going to be placed into a community VLAN. And actually, let me scoot this over a little bit so you guys can see this. Actually, let me move me over. That'll be easier. I'll do that. So there's that. So what I'm going to go ahead and do is we're going to start the configuration. Now I'm going to go ahead and I'm going to type in interface range, and I'm going to say that fast 1/0/17 fast 1/0/19 and fast 1/0/21. This guy, all these guys are going to be switch port access VLAN 11. Switch port mode is going to be access, and spanning tree port fast will be enabled. And one of the things I'm going to go do is I'm going to type in do show IP interface brief, and I need to make sure the VLAN 11 is up. VLAN 11 is up, which is good, so is the interface. Do show IP route, and let's see here. Do show run pipe begin router OSPF. Let's just make sure that I have the 172.16. Okay, I do. Perfect. So that means if I go to my home, my ASA, go ahead and pull up my ASA real quick. We'll say ASA1, and I'll log into him. I'll type in Rob and my password. We'll do a show route, and I see the 172.16 network right there. So that means I should be able to ping 172.16.11.1, and I can. That's exactly what I'm looking for. So because I can reach that, that means everything that I need to operationally is working. Actually, let me just do one more thing. I need to do a show run object network and make sure that the 172.16.11 network is there. Show run NAT and make sure that that network is available to communicate. It is. So that's exactly what I'm looking for. So I'm expecting traffic to come in and be able to talk to, be able to come in. Let's do a, so show route. That should be coming in on the inside interface. Beautiful. So what this basically means is I should be able to provide, these PCs should be able to communicate out to the internet. One of the first things that I'll have to do though, before I go do that, is I had to verify the connectivity first. Was on PC1. If I type in ipconfig, I'm going to have to go through and swap out the IP addressing. So, but I'll take care of that after I've got the configuration in place. So what I'm going to go do, the very first thing that we're going to do is I'm going to go ahead and say do show VLAN brief. Make sure that those ports are actually in VLAN 11. And they are in VLAN 11. You can never mind the ICE test. That was from me doing some ICE testing. What I'm going to go do now is I'm going to type in VTP mode as transparent. Now, because it's not required from what I gather, but I always seem to, it's just force of habit for me. So one of the first things we're going to do is we did specify that on VLAN 10. So what we're going to do is we're going to say, we're going to type in VLAN, type in VLAN 10 is going to be a private VLAN and isolated. Okay? And then we're going to type in VLAN 20, and we're going to type in private VLAN, and this is going to be community. You need to do this first and foremost, and then we're going to type in VLAN 11, and we're going to type in private VLAN primary. So by doing this, we're saying, okay, VLAN 11 is our top hierarchy, and VLAN 10 and VLAN 20 are our sub-hierarchy, which there's going to be a mapping that's done. This mapping is going to allow the communication between the primary and the secondary VLANs. So now we have that done. We have to go underneath here, and since we're underneath VLAN 11, we need to type in private VLAN association is going to be 10 and 20. Now that we have that done, next thing we have to do is at the link level, we have to go through and make sure that we apply everything correctly. So we have a little bit of configuration to do. So the very first thing we're going to do here is we have to go ahead and do some interface level config. And the very first thing we're going to do is we're going to say do show MAC address table dynamic for VLAN 10, and we have, or I'm sorry, VLAN 11. VLAN 11, we don't actually have anything propping up yet because these guys have not triggered new data yet. So what I'm going to do is I'm going to type in interface fast1/0/17. I'm going to type in the switch port private VLAN, switch ports, private VLAN. And we're going to type in the host association is going to be, we need to specify 11 and 10. And I believe when I looked at this last time, let me go up here and just double check real quick. 4C47. Oh, so I need 19. Sorry. I need port 19. So we're going to type in switch port, private VLAN, host association is going to be the primary VLAN first, so 11, and then the secondary VLAN, which is going to be 10. In this case here, it's going to be isolated. And then we get to type in interface range fast1/0/17 and fast1/0/21. We get to type in the host association is going to be 11 and 20. And we get to type in switch port mode is private VLAN host. And let's go back up to 19 and do the same thing there. So now we've got that squared away. And then what we're going to have to do is go underneath interface VLAN 11, and we'll type in private VLAN and then mapping, and we're going to say 10 and 20 because VLAN 11 is the primary one. We need to make sure that we associate that communication. And so we created the private VLAN mapping, and so those are all squared away. So we're going to jump out of here and do a show private VLAN, or sorry, show VLAN, private VLAN, and then the type. So everything's been mapped. If we do a show VLAN, private VLAN, we're going to see that everything has been mapped appropriately. So now that we have that done, we should be able to begin the next step, which is going to be, let's go ahead and release our config. Let's go ahead and release it. And let me think here, do I have a DHCP scope set? And I don't believe that I do. Let me just double check real quick on my, oh, my firewall conked out on me already. I lost my SSH session. So let me go up here and type in IP DHCP pool for VLAN 11. And we're going to type in network of 172.16.11.0/24. Do show run pipe begin DHCP. Excellent. Default router 172.16.11.11.1. That's going to be my default gateway, and that should be more than enough. So what I'm going to go ahead and do is I'm going to go ahead and it's DHCP pool 11 or local. So that should be enough. So I'm going to come in release, and I'll type in renew. So I should get an IP address in the 172.16.11 network. Say yes, and I do 11.3. And if I come back over here to PC2, the same concept should apply here. Let me go ahead and log back in. And then we'll hit the up arrow and we'll say ipconfig release, whoops, EASE. And then we'll come in here and renew. We'll do that. And then we should get an IP address, and that's exactly what should happen. Now, the server is not in the same VLAN, or is not in the same subnet. So we'll quick go change his configuration as well. We'll go ahead and, actually I should be able to go to control panel, network, view network and status, over here, properties, and we'll come in here and we'll type in 172.16.11.100, 172.16.11.1, and click on OK. That should be all I need to do. Because all that needs to happen is he needs to go out there and do a quick check and say, yes, that's a great sign. So now the question is, can I reach out to the internet and ping? So let's go ahead and ping. Let's go ahead and can I reach, now I'm on PC1, mind you. Can I ping my default gateway? Ping 172.16.11.1. Of course I can ping my default gateway. I'm connected to it. Now can I ping 10.255.10.1? Actually, you know what? Now that I think about it, I have to do 1.1. That one I should be able to reach. So there's a rule on the firewall. On an ASA, I've got 3 interfaces on my ASA. I've got 10.255.1, 10.255.10, and 10.255.100. This guy right here is used for, .1 is used for just management of my network, so that all 3 have DHCP scopes associated to them, but one is for management of devices, like if I had to deploy a web server or anything lab related goes into that. And then I have another scope, the 10 network, which is supposed to be dedicated for my home network for PCs and phones and laptops, things like that. However, when I'm dealing with Eve, I needed another NIC so that I could have management and I could have internet access. So I did that. The third one is for I've got some voice over IP phones in my house. I've got 3 9971s to play around with some basic voice over IP stuff, and that's the 100 network. So I needed VLAN separation. So that's basically how that works. So I should be able to ping google.com here, and I can. Now, the question is, should I be able to ping 172.16.11.100? No, I should not. Why can I not ping that IP address? Can I ping PC2? And PC2 is 11.2. No, I cannot. And you might say, again, why can't I? Well, that's because PC1 is in an isolated port. Now if I go over to PC2 and I ping 172.16.11.100, guess who I can communicate with? Guess who I can open up a telnet session to? 172.16.11.250 or 100. Yes, and then administrator, and then the password. There I am. I'm logged into the telnet server of the server. Telnet server of that makes sense. So that's basically how this would work. So I have that capability, and it does work, and that's the whole purpose of this whole design, is to allow communication between nodes that need to be able to communicate, and then lock down communication to nodes that don't need to communicate. And that's the idea here. So because I can talk to PC2 can talk to the server, but PC1 cannot talk to the server, they're all physically connected to the same device, right? Now if I pull up the telnet connection, or my console connection, and I jump out of global config and I do a show private VLAN, or sorry, show VLAN private VLAN, and I hit the enter key, there's no indication here that anything's incorrect. Show VLAN brief. If we look in here, from a primary VLAN perspective, they're all in the same VLAN. If we look at, no, actually, I take that back, because they're all in different VLAN, they're all part of the private VLAN design. They are no longer in the private VLAN scope. So if you look right here, VLAN 11, nothing's there. If you do a show run interface fast0/1/17, look in here, we're a private VLAN. Even though I'm in switchport access VLAN 11, I'm not actually in a regular VLAN. So there's normal VLANs, as you're commonly referred to, CCNA, CCNP communication. The VLAN is always there, right? But when you flip over to private VLANs for a security perspective, then you move away from just the standard access, or the standard VLAN, which doesn't mean the standard range or extended range. There's a standard operational VLAN. The one is just data plane communication. That goes away, and then you go into the private VLAN status. So this is where that extra level of hierarchy comes into play, and you're able to communicate back and forth. So that's basically how this comes into play, ladies and gentlemen. So beyond that, that is private VLANs. Now, I had to go and test these three specific features: the VLAN access map, the port ACL for filtering MAC addresses, and then the private VLANs capability, because the Eve instances that I'm running. So I'll show you what I mean. So I actually lost power a few hours ago for just a brief moment. It was really, really windy where I lived. So everything decided to crash. Well, I should say I lost power in the house, so all my entire network went down. So I had to spend a little bit of time rebuilding it. So, or I should say powering it all back on. So what ends up happening is these switches don't actually support VLAN ACLs, the MAC access list, or the port access list, or private VLANs. The commands are there, but it doesn't appear to work. So I used the exact same config. I had to test them out, and it doesn't work. So I was like, oh, okay. And since I have physical hardware, it's not that much of a stretch in order to show that. So what I will be doing in the follow-on videos, for doing like anything beyond this, like DHCP snooping and stuff like that, all that should be able to work on these switches. Obviously, there's a few things that I haven't tested out on these switches. I'll test them out to make sure that they actually work and stuff like that. But that's basically where all this comes into play. So there's that. And as you can see from the behind me, let me go ahead and move myself out of the way again. As you can see behind, or in the background here, I've got FTD1, FTD2, the FMC, the Web Security Appliance, the IPS. So once we're done with the with this main section of videos, and I've got all that type of stuff knocked out with the iOS firewall and layer 2 security, once all that stuff is knocked out, then we'll move on to the advanced VPN section. So we're going to jump from the 206 exam to the 210 exam. We're going to go through all of that. I will be doing a lot of VPN ahead of time, or testing and stuff like that in Eve, because I haven't done a lot of testing in it yet. So that's basically where all that type of stuff comes from. So I'm actually really, really excited about that, because I really want to dive into it. But at the same point in time, I have to be conscientious of, well, what options do I have? So a lot of that type of stuff comes into play, and we're going to be crossing that bridge when we get there. I also received a couple of direct messages through social media and asked if I was going to be doing, because I did a lot of ASA prep, if I was going to be leaving this topology alone and doing VPN with that. And the answer to that question is yes, I will. So I will have to rebuild some of this stuff because I hadn't saved the config on some devices, so not a big deal. But I'll be going through and playing around, getting all these devices back up and running. And I'm going to selectively turn on what I need and what I don't need. So I won't be, the firepower boxes, they tend to take a lot of horsepower. I'm only going to be turning on what I need, which all this stuff here in the middle, the WSA, the FMC, The FTD boxes, IPS, all that stuff is going to stay powered off until I'm ready to start testing it. And I have to go through and do some more testing with iOS Firewall. I'm almost done with it. We're almost there, but it just I want to make sure that I thoroughly test it out before I bring you guys into it. So that's basically where we are with that. If you guys have any questions or would like to see something specifically covered, please leave a note in the comments below. And until next time, guys, take it easy, man.